Hello everyone and welcome to the second video of electrochemical impedance spectroscopy. This is Sadiq. In my last video, we did a measurement in galvanostatic mode where we have a bias current of 125 milliampere and amplitude of 10 milliampere. Now, if you click on amplitude, on the top of this data box, you can see that you can either put the value in ampere, so you can have 1 picoampere to 2.88 ampere, or you can have your value in volts. So if I put here 10 millivolt, now I am in pseudo-galvanostatic mode where my excitation is in millivolt but my bias current is in current. So when we turn it on, so now here we have our bias current, and on this bias current value we have our excitation in millivolts. Now, if we look in the Fourier transform window, we have two lines for our current value, and this tells us that we are in the non-linear range, and therefore we have to decrease our amplitude. So I will click on amplitude and I will put here 1 milli. Don't forget to put here volt, otherwise if you put just 1 milli it will go to 1 milliampere, and with 1 millivolt we can see that both the excitation and the response are showing us one line, and this way we can do a pseudo-galvanostatic impedance measurement. An important thing when you are using the test sampling window is that when the measurement is going on, then make sure that your cursor is not on any active button. So for example, here if I move my cursor above count, then you will not hear this ticking sound which comes when you are doing impedance measurement, and then it could happen that here in the impedance and phase you will see some random values. But if I remove the cursor, now you will start hearing this ticking sound again and the measurement will start again. So in the test sampling window, when you come on any data field, the software assumes that you are going to change some value and then it will stop the measurement. So keep this in mind, that when you are testing your sample in the test sampling window, then you do not hover your cursor on any active button. Okay, so we talked about galvanostat in the last video. Now we talked about pseudo-galvanostatic mode. We can turn this off and we can go to potentiostat, and in potentiostatic mode you can give your bias voltage and the amplitude in volts. Now let's say that I put 0.1 volt and here I have 10 millivolt, and I turn on my potentiostat. Here I have excitation and response signal. In the Fourier transform I see one line, so my amplitude is good enough. Now if I will go back and start that recording, I will do an impedance measurement with potentiostatic mode. So I will do the measurement with the bias voltage of 0.1 volt. But if I just turn off my potentiostat, so I turned off my potentiostat, and now keeping the potentiostat off, I go back and then if I just start recording the measurement, I will now do the measurement at open circuit voltage. So the software will now measure the open circuit voltage and keep this voltage as our bias voltage and do the measurement with 10 millivolt amplitude. So again, here we start from the center frequencies of 1 kilohertz. We are going to the higher frequency, and then we will go back to the lower frequency. For this measurement, I took the EXP, the exponential setting on my test box, and you can see here that the going to the higher frequency and coming back, the data is overlapping. So this tells me that my system is stable enough. Now I will skip to the end of this measurement to save some time. So we are finished with our measurement. We can save the measurement, but I will not do this, and I will just go back. Okay, so this is how you can do impedance measurement at open circuit voltage. Coming back to the test sampling window, when we say that the amplitude is 10 millivolt, then this is the amplitude from 0 to peak, so that is 10 millivolt. But if we consider from peak to peak, that would be 20 millivolt. And with this we came to the end of the second part of our impedance spectroscopy video. I showed you that we can not only do galvanostatic impedance spectroscopy, but also potentiostatic impedance spectroscopy or pseudo-galvanostatic impedance spectroscopy, and you can also do an impedance spectroscopy at open circuit potential if you keep your potentiostat off and just start your impedance measurement. So with this, I thank you for your time, and I will see you in the next video.